Hadi, Sister Maria Zadi. Just an introduction. She's new addition in our community. Maybe 6 months before you are here, right?
Yeah, May.
Yeah, since last May she's here, and she's an engineering graduate actually. She did engineering from Pakistan, and then from Canada she has done her masters in engineering from McMaster.
From McGill.
From McGill University, and her specialized field is spacecraft dynamics and robotics. So there is a lecture today for aerospace and robotics. It's a very interesting topic for all the youth. I hope you will get benefit of that. And if you would like to pursue your career as an engineer, she's a great counselor. So most welcome to you.
Okay, can everyone hear me? First of all, I would like to know how many of you want to be engineers, so I get an idea of who will I be speaking to. Okay. So mostly the boys, the girls, not interested. Okay. So even computer engineering does come in this field of engineering. So if you're even going for computer, you will get to know about how you think and how you will be able to ensure your skills to be an engineer would be much more greater. I will tell you a bit about me when we go through what I'm pursuing. But first of all, I want to tell you about what basically engineering is. So I had a video, but I don't have sound in it, so I'm going to go over it. Because now my thing is not working. It's not working.
Yeah, in this direction.
Okay.
There is a sensor there.
It's not working. It was working a minute before. See, this is an engineering thing as well.
So sound उसमें आपका कोई वीडियो है तो sound उसमें वहाँ पे चलाएं तो sound आएगी.
Okay. Yeah. Okay, so I have a video here, so let's see if we can get sound. Otherwise, I'll be explaining what they are. I'm waiting for it. So do any of you know some of the engineering things that you have around you? Phones, yeah. Who makes the phones? I don't know, which type of engineers? There are computer engineers, there is electronic engineers. Anyone? Do you know the types of engineering? Chemical engineering? Mechanical, yeah. Okay, so I'm seeing that you don't know much about the engineering fields and the scope of it. So if you ever, the people who want to be engineers, there are over 40 different types of engineering fields. So you can go into any one of them. And the major are the four, the chemical, electronics, mechanical, and civil. Those are the four basic. But this is sort of the video about who doesn't know about engineering. It's very simple, it's for kids. If I can get, no sound. Okay. Very simple. That wasn't mine. Okay, I can come back to this. How about that?
Just look at the animations.
Oh, that's my feedback. That's actually one of the things control engineers do. They have to finish the feedbacks in your phones. The disturbance, they have to take these out. So that's a control engineer's job. Okay, I can come back to this and they can keep trying this. Okay, let's go to engineering, then you can start doing that. Okay, so engineer basically means a person who practices ingenuity. Ingenuity, anyone knows what that is? Basically someone who is very resourceful, who is very careful of the time, the cost, the materials they use. So they have to think about everything they're using. You have to know the materials you have to know the time you have to know how many people will be working on it. So a person who's able to cleverly deduce or think about or find out words of how to get everyone to finish a project. So engineer basically is responsible for that. So they solve everyday problems. So any problem that you have, okay, I'm in a very bad place. So any problems that you might have, an engineer would have thought of a problem from before. So your phones, that was a problem before, that you couldn't communicate over long distances. So that was solved by engineers by making a wireless phone. And you solve problems on a daily basis. So it's not something that you just invent out of the blue. You have to do it over a certain amount of time. So they use, and this is for everyone, they have to use math, sciences, they have to use their knowledge. So you have to be able to have some memory. You have to be able to work out problems. You have to be creative. You have to have a curiosity to solving things, to be able to look for problems and solutions. You have to be resourceful. So if you can't find something in one place, you look for another solution for it. For example, if you're making something and you need a metal pipe of some certain diameter, but you have to find out another one, you have to look for substitutions. So you have to be very resourceful. You have to design, invent, and create technological advancements. And why do we engineers do this? Because we want to improve the quality of human life. So always when you're thinking about it, why are we doing this? We have to improve the quality of human life. There has been many engineering phenomena before that were made because the humans couldn't travel between distances. So the bridges were made for that purpose. And for example, there were many failures as well because of this as well. There's a famous bridge in Canada, I believe, that actually failed. And in McGill University, if you do a mechanical engineering bachelor's, you get a ring from that piece of bridge to remind you that if you ever make a failed design or failed mechanism, it will cost you human lives. So even one error could cost you thousands and thousands of human lives. So you have to be really careful of what you're making. Even computer engineering, if you think about it, I have a story about a computing error that made a satellite fall down. So you have to be really careful about engineering. Math is essential, but we'll go to something else about it. So a fun fact for you guys, 5 of the US presidents were engineers. So you had Thomas Jefferson. He was an inventor. He actually made quite a lot of machines, but they weren't really that much famous. So he made an iron plow. He made a cipher wheel. Does anyone know what a cipher wheel is? If you've read a lot of mystery or Dan Brown books, you'll know in that. Okay, so I don't have many readers here. Cipher is basically an encrypted message wheel. If you can see about it here, I can point to it. Oh, no. Okay, so it's the wheel at the corner right there. Yeah, this is not pointed. Okay, there. That's the cipher wheel. So this cipher wheel, it had a combination of letters across it. These are all the little letters. So in only one direction, they've spelled a message out, and that would unlock. It could also be used as a transport as well. So you could have a password, and when you align those letters, an inside enclosed flask or whatever is inside, you can take that out, and it could be an encrypted message or something that you could use to transport or deliver secret messages through some means of transport. Because in that time, there weren't emails, there weren't phones, there weren't any communication. You had to give the person the letter that you had, and it was transported through another person, and then it got to its destination. So you have to make sure that what you're sending is totally encrypted by this cipher wheel. So Thomas Jefferson actually invented this. He also invented a macaroni machine. He was a person who wanted to see macaronis in the US because he went to China or someplace, and he really wanted mac and cheese. So he actually made this machine, but it didn't work out, so that was a bad invention. He made the dumbwaiter. Does anyone know what a dumbwaiter is?
It's like a small elevator for food.
Small elevator for food. So he was the first person to put it in White House, basically. A dumbwaiter for his wine. So he wanted his wine fresh out of the freezer. So he made a dumbwaiter for a small elevator. in his room or somewhere. I don't exactly remember. And you guys are not so. He actually invented the swivel chair as well. Does anyone know what that is? The chairs you probably have for your computer chairs, the ones that swivel. So he invented those. So you can thank him for all your inventions. Then James Madison, he invented something, but it's not really useful. He invented a walking stick with a microscope on it. He was really in love with nature and he wanted to see everything up close. So he invented that, but because of his height, no one was able to use it, so it didn't go that far. Then Abraham Lincoln, he was actually a land surveyor. So his job was to go on different land and survey it and see what could be built and everything. But he's actually the only patent holder. So anyone knows what a patent is? Yes? Yes, so whenever you design or invent something that's totally unique, you have to file a patent for it. A patent would allow someone else not... Yep.
Is it like a copyright?
Yes, it's like a copyright. So no one can copy your design or your invention or something. So usually nowadays what's happening, you have a patent competition. Who gets to you first? So the first person to patent something or first person to write a paper something, they get the rights for that machine whenever they build it. So it's basically a race going on in this patent. So he had a patent for a ship. He actually made bellows. Bellows is basically when you're going on water. He actually had an inflated tube around it. So whenever you have rocks underneath or any obstacle, you just float over it. Before, he was actually a very much marine person. He loved sea and he traveled a lot by sea. So he actually invented that. So he had less trouble in going towards anywhere in sea. Then we have the Herbert Hoover. He was a mining engineer. Anyone know what a mining engineer does?
Mine stuff.
They mine stuff. So it's pretty explanatory. They mine stuff. And Jimmy Carter, he was actually an engineer in the US Navy. He worked on the nuclear-powered submarines. So he was one of the engineers that is really famous in America. Okay, so we can go on. Okay, so now on to who can become engineers. So this is all for you who want to be engineers. These are the important points of how you can become engineers and what you need to become engineers. So first of all, you have to be curious. You have to be asking questions about everything that you see. Maybe a chair. How do you improve a chair? So you have to always be curious about it, and by being curious, you always end up finding some sort of solutions. Girls, I know you're not interested in engineering, but maybe something would help you here. Okay? So you have to be curious, even if you want to be lawyers and whatever you guys want, great gamers, I heard. Lawyers, gamers, and some of you don't know. So whenever you want to be, even in those fields, you have to be curious. If you're not curious, how would you be able to understand what's happening? For engineering, it's for designing something better. You have to know what's in it, how you're programming. But for any other field, if you're being a lawyer, you have to be curious if someone is doing something wrong, or if you have to know how to distinguish between different personality types. So you have to be curious about the human persona. So curiosity is a very important thing. And critical thinking. Critical thinking is the part that engineers have to learn, as well as it's a skill that they have. You have to be able to ask these three important questions. What is the problem? Who has the problem? And why is it so important to put your time in it? Okay? For example, if you're thinking of designing something, but it's like that walking stick with a microscope, do you think that will be important for someone? Very few people. Very few people. So you have to be able to understand, think about it. Is it important to give my time to this work, or to design this, or invent this? So you have to be able to think through it. So that's an important thing. You have to be able to think. And if you can see in the personality, there's no maths in the personality for some very good reason. And you have to be creative. So you have to think outside a box. You cannot think of something that's already been designed. As an engineer, you have to think about something new all the time. It always has to be something different, otherwise it's not an invention. You have to think outside the box. Communication is very important. As an engineer, you can have the best ideas, but if you're not able to communicate them to any of your leaders or boss or stakeholders, you won't get that idea across. You have to be able to present your idea in a manner that's understandable by the everyday community. You cannot use jargons. Jargons. Anyone knows what jargon means? Yeah.
It's like a language which uses enhanced vocabulary.
Yes. So jargons is anyone that uses an enhanced language in that term of fields. So if I start using scientific language right here, half of you won't get what I'm saying. So I won't be able to effectively communicate what I'm saying to you. So you have to think like that when you're presenting your ideas to someone who's not in your field. For example, you could have invented something, but you have to go to a business person to see if that idea, he will fund your idea, he will give you money for that idea. So you have to be able to get your idea across and tell him why is it so important. So you have to be a very good salesperson as an engineer. You have to be very good at sales. So if you want to become an engineer, be good at talking. Last is a collaborative spirit. A collaborative spirit basically means you have to be able to work in teams. Because as an engineer, as I've said, there are over 40 different fields. So you have to be able to work with all of them. In this time, there isn't any design or any machine that is only one engineer dedicated. If you see your phone, many engineers worked on that, not just one engineer. Even your chairs, a lot of different engineers work on that. Technologists work on that. So you have to be able to work with other people. You cannot work in isolation. You cannot work alone. As an engineer, you have to work together. Now, the skills that you have to learn to be an engineer, an aptitude for maths. It doesn't say be best at maths. It says an aptitude. So for this, it basically means you have to be good at maths, but you don't have to be the best at maths. The difference here is that you have to know what is why are we doing this in the mathematical solution. Like you're doing algebra, you have to know why you're doing it. If you're doing the geometry, why you're doing this. You have to keep asking that question if you want to be able to get into engineering. You don't follow. In engineering, you don't follow. You don't follow the herd, you don't follow the sheep, or whatever metaphors there are. You have to be able to think, why am I doing this? That's the important thing. And then you have to be able to think logically. That comes under the same critical thinking and creatively. Then the drive and determination. This is important. If you want to be an engineer, or some of you want to be in medical, you have to have the drive and determination. Because you can overcome the math problems, you can overcome the science problems if you have the drive and if you have the determination. So if you have the passion for engineering or for any other field, but you find certain aspects of it difficult, you can overcome them with your willpower, your drive, and your determination. So if you really want to be something, go for it. Okay. I actually had in 1999, Mars probe was lost due to a math error. So what was the error? They were working with another firm who was working in metric system. Do you guys know what metric systems are? The US metric and the metric system. So they were working with pounds and inches in one area, and NASA worked in metric units, in kilograms and meters. So what happened, the other company gave their measurements in pounds and inches, and NASA thought, because they're NASA, that it means kilograms and meters. So they put it in, they input it in their satellite, the Mars probe, and they sent it out. And because of that one error, the probe actually exploded once it hit the aerospace. the space when it cleared the hemisphere.
Did anybody die?
No, it was just a probe, so they didn't send any human there.
Alright.
But it actually was a simple math error once they found out everything. That's actually a job of another engineer. A forensic engineer finds out what was the problem. So if you ever want to find out what caused the destruction or anything, so that's a forensic engineer. So that they lost around, let's see, $125 million on that, just because of one conversion error. So see, the maths wasn't important. They had to know the units there. So the maths wasn't important, but why they were doing it or what it was important. Okay. Okay, so why choose engineering? So some of you here, you have to think about it that you have to do it because you're happy in it. You'll be spending 8 hours a day, 40 hours a week, 50 weeks a year at work. So if it's not something that you're happy with, don't do it. Or if someone's forcing you, don't do it. You have to be happy because of it. Because once you get there, you won't have the chance to turn around, or it'll be too late to turn around, but you can still do it. But you have to think about your personal happiness. That's main reason. Then you'll get to work with smart people. You'll get to work with all the brilliant minds of the world if you become an engineer. So that's one of the catches of engineering. You have to be the best among the best, but not the brightest. Yes, it's because if you're not the best of the best, that basically means when you're doing engineering, to be successful, you have to be the best of the best. But because when you come to the engineering field, you're not the brightest at all. You cannot think of all the ideas. You have to work in a team to think about the ideas. So it's how you work around people that's important in engineering. And that's a nice fact, the third point, is that the top CEOs of the world, and this is done by Harvard Business Review in 2018. They did the top 100 CEOs of the world, and 34 of the CEOs were with an engineering degree. Only 32 were with MBA, and 8 of them had both degrees. So what usually happens if you want to go into management, you do an engineering degree, then you do an MBA, and you go into a management position. That usually happens. If you don't want to do a blue-collar job, engineering is a blue-collar job and business is a white-collar job. So that's I don't think if you would know this, but blue-collar jobs basically means they work hard, and white-collar jobs means that they don't work as hard and their collars remain white. So if you want to do a blue-collar job, yeah?
Isn't it something to do with like you sit at the office and work,
Yeah.
and the others like you don't sit at the office?
No, nowadays it's not that true. Blue collar means you have to work hard. You have to keep moving. You're not indoors. You could be indoors as well, because robotics engineers, they're indoors. Computer engineers, they're indoors. But they're working with problems. But an MBA person, their problems are the people. They're looking at people and designating them a different field. Like you do this work. They distribute the workload. But engineers, they have to do the work themselves. So that's the difference between the engineers and the MBAs. So if you want to play it safe, what usually people do is engineering degree, then MBA. So you can see, you can become a CEO with that. And why are most of them CEOs? That's a good question if you ask that. Is that engineering makes you think. So when you're able to think, and you're able to think properly, and you're able to provide solutions and not panic in a problem, that's why they become good CEOs. They're able to solve the problems. Even if it's not a technical problem, you have to be able to solve any kinds of problem. So engineering degree teaches you that thinking ability. I've basically covered the next one, to learn how to think. And the next is to make a difference and to help people. So when you become an engineer, like doctors, you become that to make a difference. Like most people, when I grew up, I was like, I want to be an engineer because I want to make something that people will remember me after I've died as well. So usually engineering people want to do it because they want to make a difference. They want to leave their mark on earth. So that's You could do that, or you can do it like some of the like geological scientists do it to help people, like to help humanity, to help the poor people. Some people filter the water. Those are engineers that do it for the drinking problems. Some people, the pharmaceutical engineers, they find the cures to diseases, or biomedical engineers, they find cures. So you can do it to help people. There is, yeah.
How much do like on average engineers make?
It depends on the field.
Okay, how about like
Aerospace engineers are the highest paid.
how much?
94,000 is the average.
Oh, that's cool.
That's the average.
But what about other jobs? Like, what's the average for most?
The highest paid are aerospace engineers in the world. So if you go for aerospace engineer, it's the hardest field, but it pays out. And you can even get to see the space. Yep.
What's the lowest paid?
Lowest paid engineers? Well, when you're an entry-level engineer. When you're an entry-level, that means when you have no experience, they basically hire you on 50 to 60,000. That's your minimum pay in an engineer. And it could be lower depending on which field you are. But you have to be able to work out. Because in engineering, mostly what happens, the more experience you get, the more pay you get. And it's not like some field like you have to get licenses or anything. The work experience counts, the number of years.
Like, is there a certain age where you, like, it's like you're not applicable to the job, like you're too old for it?
That does happen, and it depends on the field you're talking about. For mechanical engineers, it usually doesn't happen until you come to retirement age, because it's all about something that you've done. But for aerospace, because it's such a field, and if something goes wrong, it's multi-million dollars lost, so they do look at your age. So for aerospace, if you want to do it, go young.
For aerospace, don't you need to know like different type of like engineering like combined?
No, not really. That I'm gonna come to aerospace when I get there. Hopefully, we'll get there. But I'm going to be talking about robotics and aerospace in much more detail, because those are my fields, and I'll be able to better guide you if you want later on about them. Okay. Okay. So how do you? Some of you don't know. Most of the girls don't know, and I think boys would be as well. So if you don't know that you want to be engineer, or if you have the passion for engineers, let's say you have your mindset on being a lawyer or being a doctor or being a computer engineer, but do you know about the other fields that are out there? So try out this. There are summer camps available from grade 1 to grade 9 and 10 as well, I think. I'm not sure about the 10, but I'm sure about the grade 9. There are summer camps available by University of Alberta, and also summer camps in the TELUS World of Science. So by going to these different summer camps, you can learn about the different fields. I've seen some about aerospace as well. There is astronaut trainings. There is robotics. There was also aerospace in there. So you can go and see the links. I think we'll be able to give it to you, but I'm not sure about that. We can talk about that. But there are summer camps available. There is a lot of information available on the internet for you guys to learn if you want to do this. But if you have never thought about it, I would suggest think about it. It might be something that you like. Always think about something as well. If you've never thought about it, there is always something that you might like more than, let's say, a doctor. Have you thought about cutting people, or have you thought about cutting robots? So that's the difference. You have to be able, once you enter your university level, you're all high school age, right? Younger than high school and all that, right?
Yeah.
So once you enter your university, you will have to give 4 years to that degree. You will have to persevere. You'll have to go through it. Because if you don't do it in those 4 years, you'll be changing your field to something else. If you're not sure about that, you'll be changing your field again. But you'll have to finish 4 years of it. So you have to be sure what you're doing is important. And for doctors, it's much more than that. So 4 years that, then you have to do another specialization, then a house job and whatever. So you have to be sure when you go into a university, this is your field. Okay? And there are certain student competition. This is one I found that's happening in University of Alberta. and this is actually happening on April 6th. But it happens every year. This one, its registration has closed, so I cannot tell you to go register in it. But you can even do it at a high school level. And if you do it at a high school level, if you compete in any of the competitions, you can say to your university, I competed in this, I participated in this field. And that makes your chances of going to a higher rated university much more easier. If you're outside extracurricular activities, it's for any field. Whatever field you want to do, you have to first get admitted into a good university. And for that, you have to show yourself above all the others. So imagine how many people are in your grade, in your school. Then imagine how many schools there are in whole of Edmonton. Or if you're applying to the Canadian University, how many students make up the whole Canada? So you have to be able to get in above them. So you have to be able to show what's different in you that's not in any of the others. So you have to be able to do some projects. For example, if you're volunteering someplace, showcase that. If you're making something, showcase that. You have to be able to show what's different in you and why should they take you in. That's very important. And best thing to do is your advice from family and friend. If you want to be an engineer or how you choose. So your friends and family, they know you so far. They'll be able to tell you if you have what it takes to become an engineer maybe. Or a doctor or a lawyer. It's basically, this is everything you want to be, you have to ask your family and friends. And you have to assess yourself. Do you have what it takes? Are you willing to do what it takes? Will you be able to spend 4 years at a university doing different courses of that subject, of that field? You have to be able to answer those questions before going to university level. Okay, the types of engineers. As I've said, this is just some engineers that most people don't think about. How many of you are interested in cars? Okay, I have 3, 4 people, 5. Okay, so a test engineers, what their jobs is, they test different cars and sports cars and any kinds of vehicle, and they take it and they crash it into a wall. And then they see what impact happens on the drivers inside it. So their job is to crash vehicles into a wall.
That's job.
See? You can become a test engineer.
What's their pay? Yeah.
I don't know what their pay, but it's not as high. It's probably in the 70s
Deducted from the car.
because they're destroying cars.
That's lit.
But if you can see, they put sensors on all of these cars, and then they smash it through. So it's not only walls, they throw them off cliffs, they throw things at it, they have a truck, 2 cars hitting each other. So they do a lot of cool things. So if you want to be a test engineer, you'll have to research about it because I'm not a test engineer.
Job ever.
Then there are the forensic engineers. Forensic engineers basically work with the police or the army or whatever security agency to find out why the disaster happened. For example, the bridge collapsing, the forensic engineers have to go there and then find out why a bridge collapsed. Or if a fire started, why did this fire start? From which point of origin, like where did it start? So a forensic engineer does that.
Oh, what's their pay?
I only know pays of mechanical, electrical, and aerospace engineers. But the range of engineering pay is from 60 being the minimum to 110,000 being the maximum of aerospace engineers. So it's between 60 to 90. Yeah.
What would you say is a good amount of money on average for like most people to make in the entire world?
Yeah.
For most people to
It
make.
depends on where you're living. That's
Canada.
even in Canada, it depends on which
Edmonton.
province.
Edmonton.
Edmonton, you have to be able to make 80 to 90 to survive.
A lot.
To survive.
To survive properly. Yes.
So, like, mechanical engineering in Alberta, is it, like, how
Okay,
much
guys.
do you make on average?
Mechanical
Yeah,
engineers?
in Alberta.
Because the mechanical engineers in Alberta that I've seen mostly are specialized in oil and chemical. So they have when you do mechanical, you do your specialization. So they're specialized towards the chemical industry. So I cannot say about the mechanical as it is, but their pay ranges between the same, from 60 to 90. Yeah.
What about like software engineers, like people who make video games?
Yeah, the people who make video games, first of all, you'll have to move from here, Alberta. Second of all, I actually know of people who make games. So they are mostly, do you know about EA Games?
Yeah.
Their headquarters is in Quebec.
EA Sports.
So if you want to do gaming, and if you want to be a software developer, that's the term they give, software developer or software graphic designer. So they have their company in Quebec, Montreal to be exact. So if you want to do that, I would suggest if you're doing from that, you should learn French. That will help you. Because if you don't know French, and if that will increase your chances of getting into that job. Because they'll ask you if you're bilingual or not. So if you want to, you can start learning now. It's not that hard. But it's good to have a goal.
At McGill University, do you have to know French?
Yeah. For McGill University, no. Everything is done in English. But once you're living in Montreal, if you go to a shop, like over here they say hello, or good morning, or good afternoon. They say hello, bonjour, or bonjour, hello. So whichever word you start later, if you say bonjour, they'll start in French. If you say hello, they'll start in English. So you have to know both languages to work in Montreal. So if you want to work in Quebec, learn French, if that's your perspective. Next comes design engineer. That's one of my specializations. Design engineers basically design anything from robots to rovers to toothpaste, toothbrush, anything. They can design anything, and it's all done on computers. And the analysis is done on the computers as well. So design engineer, every field has a design engineer. So before anything, you design. So design engineers are always there. Okay, next is chemical engineers. Most of you know what chemical engineers are. They work with chemicals, they work with minerals, they work with the mining engineers. Pharmaceutical engineers find cures to diseases, or they do trial runs on cancer research. There is actually cancer research going on in University of Alberta here. So if any one of you want to be one of that. And then there's architectural engineers. These days, architectural engineers are making green buildings. Buildings that have trees and plants growing out of its windows. So that's what architectural engineers these days are doing. I forgot to mention this, chemical engineers in China, they've actually made a car, and it's by Mercedes, this car, that has paint which has little solar cells in it. So instead of having a solar panels on this car, this uses the paint as solar cells to be able to drive around. So it's a hybrid car. It's an electric car which uses its paint for its energy. And it's a hybrid, so it can be both. So it's mechanical as well as electrical. But if you want to drive that, you have to go to China. But this could be...
Wait, I have a question. Like, who would make the Tesla? Like, what type of engineer would make
Oh, it's a drivetrain. In that, it's a drivetrain. It's a simple drivetrain. It's not that heavy. It's a four-person car. And what happens is that the solar cells are linked to a... Do you know what a drivetrain is? It's like a bunch of gears, and you have another chain around it. So that increases the energy output and increases the torque. It's a lot of mechanical things going on. So you need to be able to know engines if you want to go there. But it uses the energy from the solar. It increases it using gears, torques, and amplifiers, and then it's able to drive it. So it doesn't have a huge engine. It's a very light car. But you can research about it, how they made it and everything. Internet these days is so simple, you can get any information in it, but you have to be able to know what you're looking for. That's one of the things you have to be able to do. Biomedical engineers, also like pharmaceutical, biomedical engineers actually make human replica parts. So arms, legs, people who have disability, they cannot walk, they make parts from that. And some of you, if you don't know, in Pakistan there is a company that does that. So even in Pakistan, it's pretty hi-fi in that. So if you ever plan on going there, it will be nice to just go and see how they do it, because they're actually planting. I don't know if you know that, but to be able to control a bionic arm or a bionic leg, that's what these are called. You have to implant a partial of, it's a strip of electrodes to your brain, to the part of your brain that sends signal to that part of your body. So they are able to pick that signals up and then send it to that area through that wireless communication. So it's really interesting how they do it. So if you want to be a biomedical engineer, that's one of the things that you'll be doing. You'll be getting people to walk. You'll be able to see the joy of making people walk or making people hold something for the first time. So that's really important as well. Electrical engineers, you probably know about it, so I'm probably not going to talk about that. Power engineers, they're basically in your electricity, how your electricity gets to your home. Okay, I'm not going to do that. If you're going to do it if you have time. Do we have time? I think we do. Let's do that. Okay. Yeah, I have the answers as well. So imagine you're on the moon. So do you know about the moon's atmosphere? Yeah. So you're on the moon. You've landed there by mistake. Your mothership, which you have to get your stuff to, you're basically going to repair the mothership. So now you've landed on the moon and you have to go 200 miles. That's a very long distance. I tried converting that to meters and it came to around 35,000 meters. So if you understand how many that is, it's very far away. And during re-entry, most of your materials and your parts were destroyed. So you'll have to now think about these materials only. You only have these materials. And you can only take 10 items from this, because you only have that much things to carry. Does weight count on the moon?
No.
Why?
Different.
Gravity.
Because of the low gravity, you don't have to care about how much tons or pounds it is. You just have to carry about how much things you can carry and how many ways you can carry. So 10 of these things are important. 5, not so much. Can you think about them? And then tell me, not start shouting at me one at a time.
So 5 gallons of water, probably.
Yeah, water. The one top.
You can think about it, you can talk amongst yourselves. Girls can talk about that.
Wait, did you ask like,
Yeah, get the milk, man.
Well, 5 are the useless, so you have to tell me what are the 5 that are useless. So you'll have like 5 minutes. Let's say you have 5 minutes to tell me which 5 items you will not be taking.
Oh, okay.
I would not be.
I would not be.
5 gallons of water.
You can talk amongst yourselves.
Parachute silk.
Oh, never mind.
Yeah.
Question: you will not be able. You do not need your crew.
You do not need a parachute.
You don't need, you don't need to take your.
How would you carry
What
it?
if you land into the Earth's atmosphere?
How would you carry it?
Concentrate.
Why would you land? Okay, if
Do you know what's the
When you
food that
enter the-
astronauts eat?
when you enter
Do
the
you know
Earth's-
what's the food the astronauts eat?
Dried
Concentrate, dried food.
Who needs to eat? You can eat that, Hadi.
No. You're going to be traveling 200 miles.
That's fast.
Do you think, does anyone know how long it takes to get to the moon?
about a day.
No, 2 to 3 days.
That's a lot of days.
That's fast.
That's what you have to think about. Don't tell everyone your answer.
Okay, first of all, don't take your crew because there's extra weight. Survival of the fittest in my
So
life.
you're basically taking that pistol, killing everyone out.
You never know where the aliens might come in.
Yes.
Don't think about it. You have
Oh my
5
God.
minutes.
How about this?
Talk.
How about instead of doing this, why don't you start a new civilization with the new materials?
Yeah, just take
No, man.
You want that? Do you know how much a day on a moon is?
$2.
How long is one day on moon?
4 hours.
48 hours.
No.
80 hours.
It's longer than the Earth.
82 hours.
48 hours.
48 hours.
25.
120.
I don't.
160.
The whole day, one day and night combined is 4 weeks.
Wait, what? Life raft. I love it.
Yes, it's around 28.5 days.
We can.
So one moon day means
can do it.
28.5 days.
We have a
So you have 2 weeks of night and 2 weeks of day on the moon.
Oh, we need the solar powered FLSU. We're talking about something else now.
Yes, no, I'm telling you this for this exercise. So you have to be able to understand what you'll be going
We
through
want
here.
a portable heating unit, otherwise
Don't
we're
you want
gonna
to
freeze
think
to
about it?
death.
I did think about it.
You thought about it?
Yeah.
We also need the meat, so I suggest.
So we don't need a self-inflating life raft because there's no water on the moon.
Yeah, that's right.
You have to think about it. How could you use them?
Why would I cut off my
What's
own?
inside?
Air. Okay, kill one of your crew members for the meat, first of all.
Yeah, okay, so you don't need meat. You can just cut off your toes.
Why would you cut off your toes when you
You
just
don't
kill
need
someone else?
toes in space. Who needs
Yeah, you
toes?
do.
You have 1 more minute, and then we're
I
gonna
told you why
see.
we needed toenails yesterday.
We don't need 45 caliber pistols.
We need food.
You might never know how they use it.
We need some weights.
Do you know how you can use a gun though?
Yes.
Yes.
I am on.
We need the water.
Okay, fine. We don't need a gun.
Yeah, why do we need what?
Fine, we don't need a gun.
Why do we? Bro, it's not the ocean.
Okay, we don't need a gun.
Yeah, right. Why do we need a raft in space?
Cause.
Isn't there a gun for that? We need a bed, bro.
This is a thinking exercise. How can you use everything? And not
Okay, we need.
And then
We
Shani,
need a
I
compass.
figured out the fun thing. Hide the
Does
signal
moon have magnetic field?
Okay, we need the oxygen.
You know what you could do?
I found
You could attach
We need the milk.
the 45 caliber pistols to yourself.
Yeah.
Put in matches into the pistol and shoot. So you'd be like Iron Man and fly.
That's sort of why I have pistols there for propulsion, but not with the matches.
So we can have I found 5 things.
Okay, so let's go to the answers.
Okay.
Yeah.
Okay.
Can I get some of the answers? What's the most important thing?
Water.
Oxygen.
$5
Oxygen.
Oxygen is the most important thing.
Oxygen. Then you need the water. Then you need the milk. Then you need the.
Actually, would be surprised you don't need the milk. It's
What?
an extra thing.
Sandy's to get taller.
You'll be surviving on food concentrates.
You need the food con. You need the box of matches.
No, you don't. How do you use the matches?
Yeah.
How do you use matches?
Use as a toothpick.
Oh yeah, there's no oxygen. See, you have to be thinking about your environment.
Bro, we have tanks of oxygen.
Yeah, bro, yeah.
Yeah.
Suicide.
Yeah.
Suicide, give up on terrorist wins.
Okay. So over here, which are the 5 things?
Signal first. We don't need signal.
You don't need signal first.
We don't need
Okay.
milk.
We don't need the milk. Cause
We don't need matches.
We don't need the gun.
We don't need parachute.
We don't. Yeah, we do.
Yeah.
When you enter into the.
Oh my goodness, we're talking about traveling on the moon.
Wait. But I'm
We don't
want to go
need a
back to Earth.
No, wait,
No,
you
you
can
can
use
use
it. She said.
Okay. So these are the 5 things that is basically useless to you. If I can get it. Okay.
Why did I become?
I didn't format mine. So
No oxygen.
no oxygen on the moon, so no combustion. That refers to
Matches.
box of matches. Then the pistol is basically one of them as well. It can only be used for propulsion. Propulsion means to fire yourself, but you have another means of it. Instead of a bullet, you can use your self-inflating life raft for that same purposes. So you can travel much larger distances by using a life raft than a pistol. So it's not that important. Then a bulkier duplication of food concentrate is your 1 case of dehydrated milk. So instead you'll be surviving on the moon with food concentrates. What does this refer to? Magnetic field is not polarized.
Magnetic compass.
It won't work. So you have to be able to know what your surrounding is. By the way, I would say, why were we carrying that for the first place if we're going on the moon?
Okay, signal.
Yep.
You could also just look at the
From the moon, it won't be pointing to the north. Because imagine you're on Earth, now you move to moon. It'll be in a different
I
direction.
just have one question. How do you accidentally land on the moon?
You don't accidentally, you were going to the moon, but you landed in a different place. That happens. That's a very common thing.
Emergency
We're going there to build a cell phone.
Okay, and then
How many times has a probe or like any human, even a human or like, how many times has a landing been made on the moon?
on the moon, I don't know about the moon figures, but I know on the Mars, 48 missions were done, but only 28 or something made it to the Mars. That they landed.
Oh, and then did they come back?
No, they were supposed to just stay there. They were not. There hasn't been a human visit on the Mars.
How long does it take to get to Mars?
7 months.
What?
7 months.
Medicated.
So imagine 7 months. Okay, so what is only required if you're on the dark side or on the night side?
Portable heating unit.
Portable heating
On
unit.
Mars.
Does anyone know what's the minimum temperature on the moon?
Negative 28 degrees Celsius.
Negative 28? No.
Negative 50.
No.
Negative 270 degrees Celsius. I'm
No,
40.
you're minus 100 from that.
Oh, negative 170 degrees Celsius, right?
Yep. Minus 170 degrees centigrade is the moon's temperature at night. So you have to survive that. If you're on the dark side, you need the portable heating unit. But if you're on the light side, you're okay.
Does your suit have like good heating?
It's insulated but not good heating. Because if it has heating all the time on, you won't be able to survive.
5 gallons of water.
Okay. So only 5 things that you didn't need were box of matches, the 2.5 caliber pistol, 1 case of dehydrated milk, and a portable heating unit. Okay.
A trampoline.
Okay, so now why did I become an engineer? This is sort of my inspirational story. So I knew from an early age that I loved working with my hands. I had a family that didn't have stereotypes of girls and guys, that girls do cooking and guys do work. So we basically did everything, and my brothers know how to cook and I know how to fix a car. So basically my passion was to work with my hands, and that actually taught me that I was pretty good at it. Why not? And I was inspired by my dad. My dad is an aeronautical engineer. So he is the person who made me go towards aerospace, and part of aerospace is aeronautical. But then I said, why not I do better than you and I go to space? So I said, I'm going to go to space.
Wait,
So,
have you gone to space?
no, not yet. But I've learned everything there is to go into space.
If you go into space, send me one of those pictures where like you have the earth in your hand and
Like a selfie?
Yeah, like those. You know those things where you have the earth in your thing.
If I remember to do that, I'll definitely do that.
So are they planning on sending you?
No, I have to first go into an aerospace industry. Because I'm in Edmonton, I cannot. Because if I stay in Edmonton or Alberta,
Don't you have to
there
do it
isn't.
now?
It depends. Now, CSA, do you know about CSA? Canadian Space Agency?
Yeah.
They work for NASA as well. So there are many Canadian Space Agency astronauts who are engineers who've gone to space.
So if you go into the Canadian Space Agency, is there a high chance?
To go into space?
Yeah.
Yes, because it's a joint event by different countries, so you have to have one country representative in it definitely. So if you come from Canada where there aren't that many astronauts, you might have a better chance than going to America and going to
Can you do this?
We're saying we should take a cow.
You can do whatever you like in front of it. Depends on where you are.
No,
Okay.
it's not die.
Then when I was able to say that I want to do better than my dad, I found out I was good at math and science, but I loved making projects. I loved building things. We had this.
No.
Okay, guys,
Universe
can you settle down and let me tell you about different things in your life that can tell you that you want to be an engineer? So when you do something like your projects for your school, I'm pretty sure over here they don't make you do as much, but if you were able to do any building or structure with your hands, do you have more fun than just reading about it?
Yes.
What? No.
Like if you're reading about, let's say you're reading about bridges and then you're building about bridges. Which way would you learn more, reading about it or building it?
Reading. You don't know what you're building.
Well, actually, yeah, reading.
You can always, that's what engineers do, they do trial and error. That's one part of an engineer, trial and error. So you have to be able to work on it. Then I found challenges exciting, and I used to do solving riddles as a hobby. So that's one good thing where you learn how to think outside the box, you solve riddles. And if you like solving riddles, there are really amazing riddles on YouTube. So they make you think differently. You will have to be able to think differently, to think of something that hasn't been done before. And then after high school, I had two positions to go. I could have gone into medical or engineering, but I chose engineering. And doctor was because my mom wanted me to be a doctor, and I was like, I have no aspirations for it. So if you have, go for it. I'm not saying don't go for it, but you should know your options. Okay, so I did mechatronics. And mechatronics is a fancy word of saying robotics. Mechatronics is the combination of mechanical, computer, control systems, and electronic systems. So all of your engineers that you want to be, I basically did a mashup of it. So mechatronics engineers need to know what's a good structure. They need to know the parts, the components, what goes in building that.
I got lucky.
They need to, yes, I got lucky. I never knew. I'm going to tell you about that. They need to know about computers. They have to be able to program. And they need to know about control system, because whenever you build a robot, you have to make it think for itself. You have to make it autonomous. That's the term for robotic system, autonomous. So you have to make it, you can use a computer, you can use a microprocessor, you can make a microcontroller, but it needs a brain. Okay, how I got lucky is because when I was in Pakistan, I was thinking about, and I was in Karachi. So there was no aerospace engineers available at that time. And I was like, I want to go into aerospace, I want to go into aerospace. So I saw this picture, and then I saw one of the fields is aerospace. So I actually got lucky and got into mechatronics and robotics because I saw this little bit right here. These are actually all the fields that you can go into after doing mechatronics. So you can go into defense, automotive, materials processing, all the fields that are listed. So I actually saw this aerospace, and that what made my final decision. So in your life, you might have something and you're not sure about it, and you're thinking about like I wanted to become this, but I have no option. I have to stay here. Let's say in Edmonton right now, I'm facing lots of problems. And right now I can say I'm not able to go into aerospace because I'm in Edmonton. But there are always tasks or always some different method in which you can stay true to your profession. So even if you're doing any other profession and you have limitations, and believe me, you will have limitations, think about how you can get towards it, how it will make your life easier. You can always think about it. So this is basically some job of a design engineer. So we build models in SolidWorks. This is a SolidWorks model. And this is actually a FEA analysis on it. So this is a finite element analysis on the stresses of a truss bridge. So this is usually for trucks and trains. So if this fails, you're killing hundreds and thousands of people. So you have to make sure it's strong. So that's how you make sure it's strong. If you guys have an aspirations for being a design engineer, you can start making 3D models in SolidWorks right now. And it's really easy and it's not that hard. And you can get tutorials online available. And I think for 1 month you can get this trial version. So it's really good. And if someone wants to actually do 3D printing, do you guys know about 3D printing?
I think that's
Like in our school, we had this thing where we could do it. So yeah, we were like working on it. And, like,
alright, calm down. You know, that's enough.
What did you make in it?
like I was only able to complete like half of it. I wasn't able to complete the whole because it was like you had to go to the class, like you had to pick the class every week to go.
So if you want to still do it, actually Edmonton Public Library offers you the option of 3D printing anything. And I think the cost is like 30 cents per gram or 3 cents per gram. It's something like that. But they have this software on the Edmonton Public Library. It's called TaperCAD or something like that. And it's really simple. And you can design anything in it and you can get it 3D printed and you can have it. So if you want, you can design something like a keychain, a key fob or something, and then go to a library and they'll tell you how much it will cost. They'll, in the program, it will tell them how much weight it is and they will tell you what's the cost, and you can actually decrease the weight if you want, if it's being too expensive. I didn't bring my trophy that I made in, but I wanted to put that. I actually 3D printed many things. One of them is a trophy and it was like that big. But when you're 3D printing anything, you have to think about the weight, and you have to think about when you're in a 3D printer. Yes?
How much do 3D printers cost?
Oh, it depends because you can get those, one of the 3D printer, it's self-printing. So you can get one printer and it can print itself. And then you can get 2 printers. So there is a self-printing 3D printer.
Buy one, get a million.
But one is really expensive, so I don't know the cost here. But it's a self-printing 3D printers. So if you think about it, it's a nice thing that you can do during the summers. Design it and print it. Okay, so these are some of the components. If you're becoming an electronic engineer, these guys.
Can you please help me?
What's happening?
I don't know.
Alisa, you can print out a computer.
Oh, okay. I don't want to hear your idea though. Okay, so these are some of the projects I made, like robots. So these are some of them that I could think of in the last minute that I made this. So I made an LFR. LFR are line following robots. IR remote control, so I basically made a robot and controlled it by using the TV remote. So I've done that. I made a spray painting robot, and my spray painting robot was controlled by digital image processing. That's what DIP stands for. So it used a camera, and that camera was able to tell it how to paint the part. Then I had a color function control robot. So different color represented different functions that it was supposed to do. I made a ball potter, so basically people who liked basketball, I made a robot that was able to put the ball in the basket,
So
and from different distances.
So you made a basketball player.
Basketball player, but a robot.
1v1.
Then I had a PID controller. PID controllers are when you go to your heating system or your cooling system and you have that controller and you tell it to go to 23 degrees. That's where you have PID controllers. They make sure that your temperature stays within that range and it goes within the least amount of time. Then I made an underwater explorer. Underwater explorer was basically a robot that could swim. But it had a huge wire coming out of it, like this robot. It had the wire, so it didn't have that much depth it could go in. But when you're doing underwater robots, they are sort of the same as designing for space because they come with the same challenges. Underwater, you cannot have anything exposed. In space, you cannot have anything exposed. One problem in your seal and water gets into your electronics, that's the end of your robot. Same thing with space. So if you ever want to make an underwater explorer or underwater robots, that sort of makes you prepared for the aerospace industry. Then an autonomous wheelchair. This was actually voice controlled, so you can say go forward and it used to go forward, goes left, right, it used to go there, and then when you say stop, it goes.
So all these projects you made in university?
4 years of my university life.
Oh.
So you like keep all these?
I didn't get to keep all them because when I moved on to the next project, I used to scavenge the parts from the old ones. But I got to keep my last one. This was my last one, the image processing one. This is actually designed on SolidWorks I was telling you about. So this, we had to make a design on SolidWorks, test it, and then make it. So if you want to do that. Then a power generating ramp. So a speed bump, but with gears and stuff to make it. I can show you what gears are if you don't know. And then a robotic arm. That's like the most first. That's the basic first thing that we ever made was a robotic arm. Yeah.
What is that on the top right?
Top right.
That one?
Yeah.
Yeah.
That's my spray painting robot controlled by image processing. So picture controlled robot that paints.
Oh.
Yeah.
What's that? What are the two little humans doing?
That's an underwater explorer.
Huh?
That's an underwater explorer.
Is that yours? Or?
No, that's not mine. I didn't have a picture of it, so I put a picture that was sort of the common. So we had the wires same like this, and it was all shielded cables, and we had rotors that were of underwater rotors. So you had to get special rotors from China exported to Pakistan for this.
No, not China.
Did the university fund all this?
No, we had to fund everything. That was one thing, so we had to be really careful of the cost. My spray painting robot cost me 30,000 rupees.
What?
So in dollars, that's around $300.
Allah.
Yeah, so we had to fund all of the projects that we made. So you have to be able to think about the cost you're doing.
And how many people were usually involved in one team?
It depends. We were 3 people and we were the minimum people, and 4 to 5 was maximum.
Did you like get to choose what you did?
Yeah. As you're engineering, when you come to your last year, you get a project and that's totally onto you, who you choose as your supervisor and what projects you do. So that's what you have to think about from, I think the first day when we went into university, our teachers were telling us what are your final year projects. What will be your final year projects? So you have to think about that.
So is that all you did in university, like make projects?
No, that was when we were doing it, we had to learn and make projects as a side. So our final papers, exams, were our projects. Like
so there was no written exam, there
were written exams in, like, let's say math. We had written papers for the mechanical project, like the mechanical, what do I call them, courses in the starting, the basics for statics, dynamics, thermodynamics. Thermodynamics we had projects. So statics and dynamics, when you're learning subjects that are purely theoretical about how to build it and what forces you need to control. So those were exam based, but then we came up to thermodynamics, so that had a lab. So whenever we had a course with a lab, in the lab that was 1 credit and the course was 3 credits. So usually when you have courses, they're credit based. So you have a 4 credit and it's broken down into 3 plus 1. And that 1 hour means 3 hours in the lab making a project.
Oh, okay. So was programming involved in all these projects?
So this one, spray painting robot, this was programming done in MATLAB in the computer, so it was controlled by the computer. So it took a picture, sent it to the computer deduced the image, then sent out how much degrees the motor turned to paint it. So that was controlled by programming. This IR control robot was controlled by programming because we had to find out what are the signals coming from the remote, detect it, and then send it to that robot. So that was done by programming.
And what programming languages usually used?
It depends on which, if you want to do electronics, so you'll be programming your microcontrollers. So microcontrollers are the little chips inside your computer.
Yeah.
So you have to program that, and for programming that, you get, they're sort of this big and the small with, like, I think they have 56 or something legs.
Microcontrollers?
Microcontrollers and microprocessors, yeah. They are the, it depends on which one you're talking about.
Oh, okay.
Because there are one controllers that are like Arduino controllers.
Yeah.
Yeah, those are different. If you see an Arduino, there is a big chip in front.
Yeah.
That's basically, if you're an electronics engineer, you'll be coding that.
Oh.
And not the microcontroller. But I've done work in Arduino as well.
Yeah.
So Arduino, if you want, that's a good hobby to learn how to program, because it sort of helps you with the programming language, because most of the languages nowadays are turning into that language, like easy to read, easy to understand languages. So I basically worked on MATLAB, SolidWorks. For programming, I worked on MATLAB, Arduino, and microcontroller has its own languages, own reading language. That's like a whole course on itself. So that has that, and even like all of the robots I made in my last 2 years, they all had programming in it. Because as a mechanical engineer and a mechatronics engineer, I found out it's easier to make changes in the programming language than making changes in the structural part of it.
Which one was the hardest to make?
The hardest was this one. That was my final year project. Because I had to find out each and every day, like I had to take an image, and then I had to get the computer to understand all the coordinates of that picture and where to paint it. So it was autonomous, so no person was involved in that process. So for the computer to recognize exactly what's the dimension of the robot and everything, and in this robot, because it was done like an arm, so I had inverse kinematics. So inverse kinematics is that once you have the coordinates in x and y, you have to convert it into polar coordinates. I don't know if you've done that, but that means converting into radius and an angle. Because my robot only had radiuses and angles. So I had to convert that. So it was a lot of conversion, and that took me most amount of time that I had. Okay, I should go on to aerospace. So what is aerospace? Most of you think aerospace is only about this and this. It's not. It also...
मुझे picture लेनी पिछले वाले
Oh,
project.
okay.
Just. Yeah, just a minute. 1 minute. Okay, go ahead.
Okay, aerospace also involves the aeronautical engineering. So in aerospace, you have two branches known as aeronautical and astronautical. So anyone knows what nautical means? It's
Isn't that a unit of...
That's also a unit of measurement as well. It's nautical units and all that. Yeah, it's also that. But in terms of this, nautical basically means a ship carrying a vehicle carrying somewhere. So it could be aerospace. Aero means it's in an air, so it means a vehicle in air, and astro means a vehicle in space. So aerospace, you could be doing designing or construction maintenance of an aircraft, a spacecraft. Missiles also comes under aerospace, if you know that, and any weapon system. These days what's happening is that missiles and weapons are being only designed by the defense industry, and most of the universities have gone, I don't remember the exact term McGill had, but they were anti-weapons. They had a association that said we're anti-weapons, and they didn't make anything that was related to killing or harming someone. So you have to be sure of which field you want to be. And if you're
Nukes also count as aerospace?
nukes are both, because the outer shell is aerospace, but the inside part is nuclear. It's nuclear, so it's chemical. Yeah. So you have to be there. For mechanical engineers, also a good fact is that the nuclear fuel rods and the nuclear stations are designed by mechanical engineers. So if you want to be part of that. So aerospace has a lot of different things, and I want to tell you about my project in aerospace if I have time. So my project as part of mechanical engineering, spacecraft dynamics major person. So we had to work on this NASA's space habitat. NASA's actually in 2017 they put forward this proposal for designing a space habitat that they're thinking of sending into the orbit of Moon and the Mars and Earth, and they're going to be putting it in the gravitational field of Earth. So when you have it rotating around the Earth, and it's sort of like a torus shaped. So if you don't know what a torus shaped is, think of a donut and empty from the inside. So there will be people living on that torus shaped object, and NASA is thinking of making it through. Now this structure is mainly what buildings are made up of. It's a tensegrity structure, as you can see. The structure is right here. I didn't want to write it down because it's a tensegrity space habitat, evolvable, 1G, growable. It's like a huge name. So it's a very huge name, and it's done by tensegrity structures. And tensegrity structures are one of the modern day phenomena, which was discovered in 1950 by Buckminster Fuller, if you know what that is. Who that is? Okay, he actually made the shape of the football. The Buckminster Fuller shape. That's who made this structure as well. So he was more into civil and he was an inventor. He made this structure in 1950, but no one knew what to do with it until like in this decade. So most of the buildings are made up of this structure, and what this structure does is that it minimizes the mass, the amount of material a bridge or a building has. So instead of steel beams coming all the way through it, you will have 2 steel beams instead of 4, and then you will have in between cables. So the cables are used instead of the beams, and that enhances the weight by 80 to 70%. It's much more efficient. So you can see here, okay, I'm getting that. So the mass is 1,600 kilograms of this thing, whereas the International Space Station is 418,455 kilograms. Whereas the population of this habitat that's proposed is you can take anywhere from 10 to 10,000 people inside that habitat. And while the ISS space station, it only takes 6 people.
What?
Yes.
How many countries does the International Space Station?
Canada is part of it, America is part of it, Russia is part of it, China I don't think so, Europe is part of it.
Oh.
So every member from one country is there. So Russia people are there, Canadian people are there, because I know in McGill when we had one of my supervisors person, she was another colleague of mine. She actually was the person in CSA, Canadian Space Agency, which used to wake up at night giving direction to the ISS on how to repair materials on the space station.
So there's one person from each country?
At least.
Oh, okay. And then, oh, okay, yeah.
And as an astronaut, you have to be engineers as well, because you will be fixing a lot of different
So
things.
how does one person like get to the ISS and back?
They sent
Oh, okay.
ships and
And then do they switch often?
yeah, they do switch, but there is a certain amount of, like, I think it's 18 months that you have to stay in there and then come back. And before going into the ISS, they are sent on trainings.
Like every single country in the world.
No.
Like only the major countries.
No, only the agencies that are in space. So
Only the superpowers?
sort of all the
So like
superpowers.
Canada, Russia,
China.
China is not part of that.
Canada, North
For
Korea,
now, it is Canada, America,
Wakanda.
Europe, and Russia, I think are part of it. Okay,
And is the
so
Canada arm part of that?
Canada is part of that.
The
We're a
Canada arm.
superpower?
Canada arm? Oh yeah, that's part of ISS.
Wait, Canada's a superpower?
No, it's part of the ISS. Okay, so the Mars rovers. So NASA has pretty much dominated this industry of like going to Mars. So they've sent a lot of rovers. They've sent Spirit and Opportunity. They've sent Curiosity, and now they've just sent Insight. That's like the latest one. So first, what they did was they sent rovers to follow the water. Now if you've read about it in the news, they found water on Mars. So now they're gonna explore the habitat of it, like how it's living and what. And then next, that they're planning on sending a science rover that they want to seek signs of life, so aliens, Martians. So that's what NASA's overall.
Martian.
Yep. And then they plan on sending humans. In 2020 something, 2022, they have a team of humans that they're sending to Mars on a one-way journey.
So are there any
So they have shortlisted people, I think there are 20 people, who are going to go to Mars for indefinitely and live there. And it's going to be, if you want to learn about that, that's really cool. Okay, so I had a video, but I'm not playing that. So only 45 missions were sent on Mars, only 22 were successful. So that's less than 50% success rate. And actually one of them was sent by India as well. And that actually made it. So, if you want to know that. Okay, so on Mars, it's a combination of Earth and Moon. So you have both atmosphere playing against you. So you have the friction of the Earth, but you have the low atmosphere of the moon. So you cannot only rely on your parachutes to slow down. You have to think about another landing mechanism. So that's where every one of the rovers that failed was in landing. So you need a landing way on Mars. Okay guys, I know there are 15 minutes left, so please listen to me and then you can go pray and go home. Okay? So the ways of landing on Mars, so for, I think it's 48% success rate. So you have around 52% of failures. And those 52% failures only happen in the landing. So I actually had an opportunity to meet the NASA lady who actually worked on Spirit and Curiosity rover. She actually worked on Curiosity rover. And at that point, NASA had only sent down the Viking landers, which used the retro rockets, and the Pathfinder, Spirit, and Opportunity, which used the airbags. So if I get this to play, if I can get this to play, so I can show you what an airbag was. Okay, so in this we have airbag.
In a minute.
China grows cotton
Okay, so I can talk about it. So in this one, it will show you all the different ways that NASA landed. So at that point, they had retro rockets, and then for the Spirit and Opportunity and Pathfinder, they thought of what's the best way to protect something that is falling at a very high speed. So they thought of airbags. In a car you have airbags. So what they did was they put airbags all around that rover, and it was jumping up and down and following. That's the airbag. So that's how the Mars landed its first 3 rovers. That's the second rover, the Curiosity. No, that was the. That's Curiosity.
How did this one?
Yeah. For Curiosity, what the problem they had, and she was able to tell me, was that because it was so heavy and it wasn't able to fill it with airbags because it was heavy and it was really huge. So they actually thought of combining the 2 different methods. So they had retro rockets, but because it's a rover, they didn't want the rockets traveling around with the rover. It's a weight that needs not to be carried. Let me finish that and I'll come back to you. So what they did was they had a retro rocket, another machine that was able to disperse after it was done its job. So the rocket lowered the Curiosity rover on the ground, and then it flew off to be space garbage, basically. We have a lot of space garbage, by the way, and there are people that are working on clearing the space. That's one of the jobs. 1 second. Yep. What was your...
What does NASA stand for?
North American Space Agency.
National Aerospace.
North American.
It's something I actually forgot. It's a space, so I don't know exactly.
How about those South Americans or the Europeans?
Okay, yes, you had a question.
Wait, what does that stand for? What does that stand for?
I actually don't exactly know. It's aeronautics, something space association. It's aeronautics. Yes, you had a question.
It wasn't a question, like, doesn't space garbage cause like many accidents?
Yeah, that's why they're making. There has been some cables and pulleys. They were designed by a McGill professor because I was working under a spacecraft supervisor. So he actually had many students working how to clear the garbage. Basically, they had these cables shoot out at certain angles. Then they grabbed the garbage and they threw it away. We're still putting garbage, but not in the Earth's atmosphere. So you have to, if you want to be in aerospace, you also have to think about clearing all the garbage that you're doing. Okay. Let's go to, this is something that happened very recently. It happened in January 3rd, 2019. And China was the first person to actually go to the dark side of the moon and grow these cotton sprouts, which I have on the next page. So they planned on having a whole habitat grown there. So they had this plants and potato seeds. They had a silkworm larva that they planned on, if the plants were succeed, they would provide the oxygen for the silkworm to survive. and that would cause the silkworm to provide the carbon dioxide back to the plants, and then we might get potatoes, like in the movie Martians, we grow potato plants. So they had that plan. They had that plan of growing potato on the moon.
Yo, space fries.
But what happened? But what happened? Okay, my pictures are not working. The picture didn't came.
Nemo.
Okay, so there was a picture here of the cotton sprout which didn't come, but it's actually one germination of that cotton sprout. But after 2 weeks of day, night came and minus 170 degrees hit the poor plant and it died. So everything that they sent on the moon is now garbage, basically. But they sent this rover. If you can see this rover, they sent this rover, and this is named as Changi 4. So now this rover is on the dark side of the moon.
We have discovered big trees.
And they were the first people to land on the dark side of the moon. Do you know why the dark side of the moon is like they were the first people to go on the dark side of the moon?
Because
Heat is not a problem.
no, sorry.
On re-entry, a rover goes through 2000 degrees centigrade of heat. The problem was that on the other side of the moon, no signals go there. So you have to put another satellite in orbit of moon to be able to communicate to that rover. So that was the problem that China overcame. Okay. So I didn't. Okay, this is one of the this is the expedition that they do for training the astronauts, and this is done outside of Florida, and there are many different Canadian astronauts there, if I can get the names of them.
Have you done this?
No. Yep.
Do you know Chris Hadfield?
Yep, I haven't. Chris Hadfield was the first astronaut to do spacewalk.
He came to my school.
So which one?
Oh, he did?
Yeah.
That's really good. He was Chris Hadfield, if I can get the third in it. This is actually Chris Hadfield. He trained on Nemo, and he was the first Canadian astronaut to walk in space. He was the first Canadian astronaut to walk in space.
Wow.
Yeah. And I think it was in 2014. So no Canadian astronaut had done a spacewalk.
The spacewalk is walking on like another planet, or just like in
No,
space?
walking out on space. The astronauts when they
So
go to
like they
fix
enter,
walking.
so they exit their spaceship and they have a little 2D thingy.
Yep.
And then they made
Okay, and
Oh my god.
this person, he's now currently on Nemo expedition, and his name is Jeremy Hansen. He's another CSA astronaut. He has a Bachelor of Science in Space. So he's done his BS, Bachelor of Science in Space Science, and he's done Master of Science in Physics. So if you want to know about. So this person is David St. Jacques. He's actually an engineer, and he was sent to discover different rock samples. So he did rock sampling on Earth. He was an engineer, astrophysicist, and a physician before joining CSA. So if you want to look at different things, if you can go into space.
He has no.
So why is Nemo done there? Because you have to be able to tackle the challenges of the underwater. It's the same experiences as you will do when you go into space. So you have to be able to go outside for a long time. You have to be able to wear your whole gear in that time and do sampling, rock sampling. You have to be able to do digging with all your suit and everything. That's different. Underwater you have the same gravitational pull, the same pressure as applied in the space. So they need to do this to be able to be better astronauts on different environment. And also because they're cut off from all the technologies of the world. So they're basically living like 3 or 4 astronauts are living in this secluded area underwater. And they're there for 18 months to 6 months, different times depending on their missions to the different planets. Okay, and aerospace So I had to change that. It's 74 is the minimum pay you get, and the average pay as well. The maximum, and you can see there, it's one of the highest paid careers in the world. So aerospace engineers are the highest paid careers in the world.
I can name a bunch.
No, highest paid.
Athletes. You have doctor.
Athletes.
I mean
Career.
engineering.
No. Careers. It's why athletes are not paid. Look at it over time. How much can an athlete work?
Well, actually, the maximum you can do now is 8 years. But back then, you could do like 50 years.
Now, how much longer
You know
can
what's
you
funny
stay an
though?
engineer?
Can I tell you a funny thing? Okay, so there was this goalie back then. He signed like a 30-year contract with the team. He retired, and the team's still paying
Has to pay it
him.
because you're a contract. Yeah. So if you look at it, engineering, you're doing it over a long time.
And that goalie's now
You
a
have to
general
be.
manager.
And also as an, okay guys,
his
you can stop talking now. As an aerospace engineer, you have to be very versatile. So you won't be doing one thing all the time. It's not a one repetitive task. It's a different task every day. One day you'll come to your job and you'll be doing something else. Like, for example, the NASA scientists that worked on the rovers, they had to schedule their day around the Mars day. So because Mars day is a little bit longer than the Earth day, so they were coming to work at different times of the day. Sometimes their job started at 6 a.m., sometimes at 8 a.m., sometimes at midnight. So they have to work around their projects, basically. So it's a very versatile job. What's a bad thing about aerospace? Because it's rocket science. That's my main thing. It's rocket science. It's going to be hard. You have to learn about everything. You have to learn about all the engines, all the jetpacks, all the thermodynamics, the thermal radiations. So it is rocket science. It's going to be hard, but if you have the courage, if you have the drive, if you have the determination, you can go through it. And there are physical dangers. So you'll be working with rockets, you'll be working with fuel, you'll be working with parts that are more, they'll be more bigger than you basically, they'll be higher than you, they'll be...
Good job security and working conditions. Physical dangers.
So there are physical dangers, you can get hurt. And as an aerospace engineer, you have to be continuous studying, like medical. You have to be updated with all the technologies that come in at the point of your working condition. And it's highly competitive. As I said, only few make it. So you have to be really competitive to get there. And because you are in Alberta, you will have to relocate if you want to go into aerospace industry. Unless you want to go into the MRO. MRO means maintenance, repair and overhaul. So that is in basically aeroplanes. So that's mostly done in Western Canada, which is basically Alberta, Calgary, mostly Calgary. So if you're staying in Edmonton, you have very few outlets of working as an aerospace engineer. So you will have to relocate. If you want to go into manufacturing, most of the companies are in Quebec. So you will have to go to Quebec to learn French. Because 52% of the manufacturing agency are in Quebec. Only if you plan on staying in Western Alberta, Western Canada, only 15% of the manufacturing companies are here, and they don't take entry-level engineers, they take experienced engineers. So you have to get some experience. So this is very important. You have to think about where you want to go. If it's in MRO, then good, you're here. But if it's in manufacturing, think about relocating.
How many jobs are there?
Okay, what happened?
It's magic.
I had just one more slide. It was about robotics and mechanical engineering. So the pros and cons about robotics. Mechanical engineering actually.
Here to fix this problem.
Put them out.
What do I have to do?
Just put them out. The remote.
He's sleeping.
Already down.
Okay, I can just tell you the pros. Can you go to the last slide? The last slide. Two more, one more. Okay, mechanical engineering. If you plan on doing mechanical engineering, the scope is huge. So from mechanical engineering, you can go into aerospace by doing work in an aerospace agency. There are within the top 25% of the careers, highest paid careers, because they do tend to go towards the aerospace as well. So aerospace engineers are background in mechanical, so that actually works. As a mechanical engineer, most of them are indoor, but if you go into the maintenance and the repair part, that sometimes does happen in outdoor, but mostly it's now indoors because you'll be working in industries and that's all indoors. There is a lot more recognition and career advancement in mechanical engineers as compared to other industries because you can always specialize in one field, and it's only suitable for certain individuals. So that's sort of a pro and a con depending on yourself. The con is that it's not project based, so you will be doing one work repetitively every day for the rest of your life until you change your job. So think about that, and you will need to be hardworking and determined, but in this you won't have to be continuously updating yourself with the new technologies. So that's a pro over the aerospace industry, but the same amount of hard work and dedication is required. The working hours are long as usual, and it's a repetitive task. So that's all about. I don't have a thank you slide, but thank you.
You're welcome.
You're welcome.
At least you like
Thanks very much, Sister Maria. I'm thinking that now I'm an aerospace engineer. So much information which I learned today. Really. Thanks very much for your hard work. And say a loud salawat for Sister Maria. Allahumma salli ala Muhammad. And thanks very much for all of you in participating in this program. Our next program will be on February 24th. So just remember, and many thanks to our sister who make tea for you. So there is a tea available if you like to have the chai. Yes, sure. So thanks very much, and I will request all boys, please help us to fold the chairs and put it on the other side because we will have a prayer here now.